So let's look at an example of Bayes' rule. So let's do it in the context of you getting an A in a class. So let's make this your event of interest. Getting A. So if I asked you, what's your probability of getting an A in a class? Maybe you might base it on your previous classes and how well you did in those. So you tell me 80% chance I'll get an A and 20% chance I won't get an A. Not A. And now let's define our terms for this simple probability. So your probability of A equals 80%, and then the probability of not A, which we're going to denote as A prime, because it's the complement of this event, is 20%. And notice these equal to 100 because they're complements of each other. Either you get an A or you get something that's not an A, whether it be a B, a C, a D, F, whatever it is. And then another part of this notation is the probability of A equals 80%. Probability of A prime equals 20%. Okay, now let's say you get new information. Info. And this new information is that the class is really difficult. And difficulty plays a big factor in whether or not you get an A. So you have to revise your probability of getting an A to something that accounts for how difficult the class is. So this is your condition. Let's say you go around and you ask 10 people, and this is a random arbitrary number. You ask 10 people that got an A whether or not they took a difficult class. So the probability of someone who got an A having taken a difficult class is 10%. So the probability of having taken a difficult class, given that you got an A, is 10%. And let's say you ask another 10 people who did not get an A whether they took a difficult class, and they tell you, or you find out that 60% of them did not, 60% of them took a difficult class if they did not get an A. Okay, so now this is your information. You've got a sample, you collected it, and this is your condition. Conditional probability. So now, with this new information, you can ask, what is my new probability of getting an A given the class is hard? So this looks like probability of A given difficult. Now we can fill in what the information we have. So probability of getting an A is 0.8. Probability of not A is 0.2. Probability of getting an A given that the class is hard. Well, we actually don't know those. We would be looking for the probability of D given A and D given A prime, which is what we've collected here. So that is 0.1, and this is 0.6. And remember, these here tell you if you have a group of people that got an A, how many of them or what percentage of them took a difficult class, and the same thing with A prime. So now the joint probability and the revised probability, we're going to visit a little bit later, but let's look at the formula for right now. So this is the formula that we saw in class. And first thing we want to do is change all of our variables to be correct. So I replaced all the BI's with A and all of the A's with D's, because this is what we're trying to find out. And so we see that here in this formula. Now the numerator here looks pretty familiar. It's the multiplication rule. Now the multiplication rule is used when we want to find the probability of two things happening at the same time. For example, January, and Wednesday happening at the same time. This is also known as the joint probability. So here we're finding the joint probability between you getting an A and it being difficult. Or in other words, the probability of you getting an A and the class being difficult at the same time. So of those happening at the same time. And now for the denominator, it looks a little funky, but what it's really saying is the joint probability of you getting an A and the class being difficult, those events happening at the same time, and then the joint probability of all the alternatives also. So you getting a B and it being difficult at the same time, a C with difficulty, F with difficulty, etc. So because we've lumped all of these alternatives into A prime, so A prime is B, C, D, F. It's all those alternatives. We can simply replace this portion with A prime. So it looks like this. Probability of D, so this is the joint probability of it being difficult and you getting an A. And then we see that again here. And now we took all this and lumped it into probability of D given A prime, probability of A prime. And the reason why this works is because the denominator of Bayes' theorem is just the joint probability of all of the alternatives plus all the events of interest too. Okay, so this is what it looks like if we plug in the formula. We have all of our variables here, so the probability of you getting an A, and the probability of you not getting an A, and then your joint probabilities that you figured out through your little survey. And now we can plug them directly into here. And it says here that you'll have a 40% chance of getting an A given that the class is difficult. Now one more thing, I want to connect this calculation to the joint probability that we see here. So the joint probability is just the probability of both the conditional and the simple multiplied together. So it'd be 0.8 times 0.1. And remember, we see this in the numerator. And that equals to, it's right here, 0.08. And then the joint probability is the conditional times the simple, 0.2 times 0.6, and that equals to, right here, and that is 0.12. And then if you notice, we have our 0.08, our 0.12. If you add together the joint probabilities, you get your denominator. So we can find the sum of the two joint probabilities, and that becomes our denominator for the revised probability. And then we take the joint probability of each one of these, 0.08, 0.12. Now we have our two revised probabilities. Here's your 40% chance of getting an A given the class is difficult, and then this calculates to 60% probability of getting an A, not getting an A, given that the class is difficult. And because A and A prime are complements of each other, these two probabilities will equal to 100. So that's a little rundown of the Bayes rule. And if you have any questions, you could ask me. And hopefully this helps you to understand the basic concepts of conditional probability, simple probability, and joint probability. All right.